Have you ever pondered the significance of closed ecological systems? These are self-contained ecosystems that do not rely on matter exchange with external environments, almost like miniature worlds within our own. The beauty of these systems lies in their circular nature. Waste products from one species become valuable resources for another, creating a cycle of use and reuse, just like the circle of life. These systems often play pivotal roles in scientific research and hold promising potential for space missions. Imagine a spaceship with its own self-sustaining ecosystem, providing life support for astronauts on long voyages. Sounds like science fiction, right? But it's not. Real-world examples of such systems exist, like Biosphere 2 and Melissa. These projects have shown that it's possible to create a contained ecological system that can support life indefinitely. But these closed ecological systems aren't just fascinating scientific experiments. They also teach us valuable lessons about sustainability and resource management. They show us that everything in nature has a purpose and nothing goes to waste. It's a lesson that's more important now than ever as we grapple with environmental challenges on a global scale. Closed ecological systems are self-sustaining worlds within our own, but how resistant are they to outside contaminants? What happens when the barriers of a closed system are breached by invisible invaders like microplastics? Imagine a cave system in Missouri, sealed off from the public for 3 decades. It's a subterranean wonder, a hidden world untouched by human hands for years. Yet scientists have recently discovered high levels of microplastic pollution in this very cave. Yes, even in the absence of direct human activity, our pollution has managed to infiltrate this secluded sanctuary. Microplastics, tiny fragments of plastic smaller than 5 millimeters, are a major environmental concern. They originate from a variety of sources, including broken-down plastic waste, industrial products, and synthetic textiles. These tiny particles are virtually indestructible and can remain in the environment for hundreds, if not thousands of years, posing a significant threat to our ecosystems. In this Missouri cave system, a study led by Elizabeth Hasenmuller found microplastics and cellulose-based pollutants in the water and sediments of Cliff Cave. Sediment within the cave contained about 100 times more microplastic particles than the water. Intriguingly, the concentration of microplastics increased in the water during flooding events. This suggests that floodwaters act as a conveyor belt, transporting these invisible invaders into the cave where they can linger for extended periods. This discovery raises alarm bells. It's a stark reminder that our actions have far-reaching consequences, even in places we consider secluded or protected. The presence of microplastics in such a remote environment shows just how pervasive and persistent these pollutants are. More worryingly, it highlights the potential risks to fragile ecosystems and our water resources. Think about it. If microplastics can infiltrate a closed-off cave system, what other unseen places might they be invading? How might they be affecting the delicate balance of our ecosystems? And what can we do to mitigate their impact? This discovery underscores the need to understand the sources and longevity of microplastics in these hidden ecosystems. Why should we care about microplastics in a closed cave system? It's not just about a solitary cave, it's about the health of our entire planet. The presence of microplastics in this isolated environment showcases the far-reaching effects of human pollution. It acts as a stark reminder that our actions can leave a footprint on even the most secluded parts of the world. This discovery also has broader implications for other closed ecological systems, like Biosphere 2 or space station habitats, which are designed to be self-sustaining and isolated from external influences. If microplastics can find their way into a closed cave system, what's stopping them from contaminating these man-made ecosystems? The answer is unsettling. Not much. But there's a silver lining to this cloud. This research can act as a catalyst for future conservation efforts. It underscores the importance of preserving these unique environments and prompts us to rethink our approach to pollution management. It's a call to action, urging us to develop more sustainable practices and policies. This isn't just about caves or biospheres or space habitats. It's about the bigger picture, the health of our planet and our responsibility towards it. Our actions cast long shadows even into the hidden corners of our world. It's more crucial than ever to understand and mitigate our impact on these closed ecological systems.